Kelly Bauman is the Manager of Distribution Automation Engineering and Operations at Entergy. He has design and operations experience in distribution, substation, transmission, and system operations control centers. Kelly is responsible for distribution system protection, automation, and control technology deployments, such as Scada, DMS, Recloser, CBR, and BDO, and is part of a technology and infrastructure deployment of roughly $500 million over the next 5 years. Kelly lives in Baton Rouge, Louisiana, and is an active member of IEEE PES. Today, Kelly is going to be joining us remotely, but not only is he remote like most of us are today, but he's going to be remote on his mobile phone. So he's going to instruct us when to advance the slides to the next slide. So with that, please join me in giving a warm welcome, warm virtual welcome, that is, to Kelly Bauman. Kelly?
Good morning, and thank you, Wayne, for the introduction. So today I'm just going to briefly go over Entergy's distribution automation program and sort of skim over the top of a number of different areas and investments that Entergy has going on at the moment. And then if there's any questions and deep dives that anyone would like to have information on, we can handle that as well. So today, Entergy has 5 operating companies: Arkansas, Mississippi, Texas, Louisiana, and New Orleans. Across the Entergy footprint, there are approximately 1,500 substations, resulting in 30,000 megawatts of power produced, and 9,000 of that being nuclear generation. Entergy has approximately 2.9 million customers and 13,000 employees across the 5 operating companies. So while Entergy maintains some of the lowest rates across the country, we also recognize that our customer expectations and demands are evolving. So the utility must do that, and we recognize that as well. This is a summary of the current investments across our distribution system in terms of what we encompass and call grid modernization. Grid modernization has many different components between a new customer digital interface, a first deployment of advanced metering infrastructure, a new outage management system and distribution management system, including ADMS functionality, an enterprise asset management and workforce management system that are new as well, the distribution automation program, which I'm really going to touch more on in this presentation today, and then an infrastructure program for our existing and new equipment facilities on the distribution side. So you can see that there are a large number of investments and programs in flight at the same time, which is both challenging, exciting, and difficult to accomplish while everything's in the air going on in parallel. Today and historically, Entergy is not new to DA. We do have approximately 700 automated switches across our service territory. Those would be the red dots on the screen. And then of those 700, only about 30% of those are connected to our Scada system. So we have quite a number of automated switching activities going on in the field that we have little or no visibility to. So that just kind of gives you a feel of where Entergy has been over the last 10 to 20 years, putting in schemes across the system. So this picture is a good summary of where we've been. Typically we have a high level of Scada visibility and control from our central generation stations across our transmission system over into our substations. And then as we move over into the distribution system, we have very low level of visibility and control through our primary and also our secondary, which obviously now our AMI system will improve that as it's put in, and the DA program will fill in the distribution primary. Go ahead and flip to the next one. So this outlines sort of our future state, right? So we will have end-to-end visibility and control and much more information and data coming in, as was mentioned earlier with ComEd, starting to leverage things as centralized ADMS functions, including Recloser, self-healing networks, volt bar optimization, conservation voltage reduction, and improved data for our asset management and planning models. So a couple of good scenarios of what the DA program is adding and how it adds value at Entergy. This is an actual picture of one of our above ground vaults in the New Orleans Central Business District. We actually have crews today that still roll around in kind of bread trucks and look for light bulbs turned on because they don't have their equipment connected to the SCADA system. So that's our underground networks there. So it gives you a real tangible view of opportunity that we have out there. And it's also really cool from an engineering perspective of how they maintain operations day to day with light bulbs. So sort of a good example of not only where can we go, but also where we're at. For our reliability improvements that come with the program, we have a number of new self-healing networks or automated reclosers that we'll be deploying. And so with those, they'll be at least starting out acting in decentralized schemes connected to our SCADA system. Excuse me. With those, we can switch and restore power automatically when a fault does happen. It obviously does not prevent a situation or a fault across the system, but it will restore and isolate as small of customer accounts as possible. From a benefits perspective, Entergy is forecasting approximately a 38% reduction in SAIDI and an 18% improvement in SAFE. So this just gives you a feel about the amount of impact that this program will make over the next 5 years. To do so, as I mentioned, we're deploying a new AMI system across our territory. This will be the first time AMI for Entergy. And then in parallel, we're expanding that network to also support our DA devices. So you can kind of see on top the red line, this is the infrastructure and equipment leverage for AMI. And then there's a converged network across our field area network with the APs and relays. We're adding about 10,000 nodes to an existing 15,000 being deployed with AMI to result in about a 40% share of the overall network infrastructure. And then the bridges or the radios on the bottom left, that would be the quantity that we're forecasting for all our devices that we're connecting to the network and across our data centers and ultimately tying into SCADA. From an equipment perspective, you can see the device quantities that we're looking at deploying, so ranging from new reclosers, substation automation, a smart line sensor program, upgrades to our current standards for capacitors, switchgear, network protectors, pretty much any of our line and field devices. We're either leveraging capabilities that they have or installing new devices to support the benefits and capabilities across the system, and even replacing some of our older and legacy assets. Another area that I think is very important to share as part of this, our vision is to connect our equipment, integrate that into our SCADA system, connect it to our distribution management system, and really drive home that improved central monitoring, visibility, and control of the system, in addition to further sectionalizing and creating more self-healing networks, which will improve both our operations and our reliability. A key component to that is our SCADA standards that we're developing. Historically, we have not really had any consistency in terms of what is our process to connect the device into our SCADA system and ensure that it adheres to a standard philosophy and versioning and change control process. Today, we have that in place as of recent, and so now you can kind of see the standards that are built into this, and then ultimately, what the outputs are. So taking a device from, I've got a new project into this is what's submitted, and here not only commissioning that into our SCADA system, but long-term also having it roll in and integrate into our DMS. I'll just share that, historically at Entergy, it would take about 6+ months to commission a device. We've taken that process down to less than 2 weeks. Even this week, we commissioned over 10 devices in a single day. So a substantial improvement in terms of our SCADA standards and our ability to integrate equipment and devices across our network and into our control centers. In order to do this, we've also created a new lab in the New Orleans area. So I'd encourage, If any of you are down there and like a tour of that, obviously after the pandemic situation has resolved, feel free to reach out. It is intended not only to do testing, but also to show off the work that we've been doing and help spread what we've learned. So for internally at Entergy, control room operators can come and operate a mock system that's at the lab, including LED circuits, the same controls, and also the same screens that are at our operations centers. Our engineers can test, develop, and troubleshoot issues ranging all the way from our DMS system to our Scada system to our controls in the same room. And obviously our linemen and servicemen can come in and have hands-on with the equipment and touch the buttons and see the outcomes, not only in front of them, but also how it impacts our operators back at our control centers. This next slide shows a quick rendering of what the 2B state is in the lab, and then actual below that, the progress that we have to date. So you can see a lot of work has been done. If you've seen this facility before this started, it was an unconditioned warehouse. And so we are most of the way there. We're waiting on some last minute equipment and electrical to be completed, as well as we're finalizing the installation of our test SCADA and DMS system there. So this center will be state-of-the-art in terms of developing, testing, troubleshooting, and also even doing some monitoring of our equipment once completed. So in a nutshell, just to wrap up the Entergy DA program, we range from, reducing power outages and improving reliability. We are expanding our communications network to support our line equipment. There are a number of new standards changes and technology upgrades for our actual equipment out in the field. We take the DMS, OMS, and ADMS functionality that we're actively deploying, and we're also expanding and enhancing that to do additional use cases that provide, bottom line financial value for both our customers and internally to the company. Our self-healing network deployment plan, I think we have around 2,100 reclosers being deployed over the next several years, so that's a large part of what we do from an engineering perspective. Settings, development, and protection, as well as equipment monitoring of the conditions coming back from our devices after they're connected to the network. We've also added a number of IT and OT resources to support our SCADA commissioning and our long-term roadmap, and in addition to not only these devices, but I think DERMS was mentioned and DER, and what's really going to be needed for day 2 in terms of not only just deploying additional self-healing networks, but the DER that's continuing to come across our territory. There's device deployment plans included in this, and also the lab that I mentioned. So that's sort of a glaze over the top in terms of all the things that we have going on from a DA perspective at Entergy.
Okay, thank you very much, Kelly, for that interesting presentation, and congratulations as well on the opening of the Dart Lab. It really looks like quite a place to showcase, and I'm sure you'll have a lot of interest in tours after the virus subsides. And again, thank you for joining us remotely. As mentioned earlier, this is very much an interactive webinar, so please continue to post your questions. There are a lot coming in. And on that note, I will now turn the microphone back over to Eugenio for questions from the audience. Eugenio?
Yeah, thank you, Kelly, again. One of the questions here is in regards to the communication that you described us. In one of the slides, you had the AMI and the DA sharing the same communication. So the question is, how do you see the communications reliability on using the same network for DA and an AMI?
Yeah, great question. So for our AMI deployment, we have about 1 million meters of our 2.9 currently deployed. In addition to that, we have roughly about 130 of our new reclosers commissioned to SCADA. So we're really on the bleeding edge of understanding that. I would say from a specification perspective, we have developed and included in the network design different specifications in terms of operations and even service level agreements on how that converged network would function. I would say that we have split into a few different categories between meter traffic versus device traffic, and then also critical device traffic to be leveraged during an outage scenario versus a little bit less critical traffic, meaning a capacitor bank or a regulator may send information updates as it changes taps or switches in and out. It's typically not going to be a high need during a time of outage when I have not only last gas traffic, but also switching going on. So those three buckets are the start of how we're designing the network and planning to watch this as it goes. We're going to continue to monitor that and see, is it performing as designed, or are there tweaks that we have to make? Additionally, from our meters, when we do have last gas, we have the super cap embedded into the meter, which will buy us a little bit of time in terms of getting our switching done prior to the network starts to flood with the converged traffic. So this will be an interesting thing. We've thought about this for a while, and we're going to continue to monitor as it goes. And I'm looking forward to seeing, truly what the outcomes are, and we hit it right the first time, or there's some tweaks that we have to make.
Thank you, Kelly. So there is one question here in regards to your lab, and actually one comment before that, it's probably the dream of every distribution group to have such a lab that you have or that you are building. And the question is, where is the lab located? Is it in New Orleans?
Yes, it's in the New Orleans area. It's pretty close. If you're familiar with the Superdome, it's pretty close to the Superdome.
Another question for you, Kelly. It looks like your AMI is from Silver Spring. Are your APs using cellular as a backbone?
Yeah, that's correct for the most part. So the network was designed to be able to be expandable. So for example, we talk about the Superdome in New Orleans or the CBDs or Mardi Gras. Obviously, cell coverage, can be impacted during times of high traffic and crowds. So kind of two methods. The backbone, the typical backbone for the network is to go across the 900 megahertz mesh. As mentioned, it is through traditionally Silver Springs, now Itron, similar to what ComEd had. A little bit different architecture, but in terms of the vendor. And then we do converge from the 900 megahertz mesh over to cellular backhaul. Now, as a backup to that plan, as I mentioned, with crowds in different high traffic areas, we do have the capabilities to install our access points at substations where necessary. So we're looking at not only the network performance, but also what conditions could cause issues over cellular, and we're allowing those to be mitigated by substation connections as well, back to our fiber and backbone.
Thank you, Kelly. Another question about your Scada system. Will you need to upgrade your current Scada system to support the additional data coming in from the distribution system?
We have upgraded, I'd say, our front-end instance to Scada to allow all the different connections coming in from the devices. From a point perspective and the amount of data, we have not had to make any changes yet. We are forecasting that out, how many points, how many controls that are coming through. So far, we have not had any issue after enhancing the amount of connections that we have.
Thank you. One about your Fleaser scheme. Kelly, you mentioned about Fleaser as being one of the areas where you guys are working on. For the Fleaser scheme, are you implementing a centralized or decentralized scheme?
Sure. So today and historically, we have been decentralized. I would anticipate a number of decentralized schemes will remain long-term for things such as hospitals, industrials, and areas that I'm trying to move quickly. Other areas that are more residential, and I'd like to be under the 1 minute mark, there's opportunities to convert over to the decentralized approach. So our ADMS that we're installing is capable of Fleaser. we're currently looking at that from a capability perspective, as well as going back to the network question, right? Is can we get all the traffic across the network quick enough to execute the switching orders before the outage and last gasps had happened? Thankfully, we have decentralized approach today that we can fall back on. And then as we deploy the ADMS, we're going to continue to work with that and hopefully and ideally move over to the centralized platform. So ideally, we will convert from decentralized to mostly centralized, with a small percentage of the industrials and hospitals that will still remain decentralized. So I would see us in a hybrid state, 5 years from now, but today we are 100% decentralized.
Thank you. Another question that related to communication as well, in this case, the latency of the communication. So what is the latency of the SCADA communication from field device to DMS? And I wanted to add, if on top of that question, if you have any specific requirement on that, and if you have also real data and measurements of that latency.
Sure. So we do have requirements around it. We're looking at 2-second round trip time over our mesh and cellular, and there's also a couple second add as you move back through your data center and into your SCADA system. So I would say by design in total around 3 to 4 seconds. So far, we're so early into the deployment and really starting to see results come back. It seems to fall in line with that, where our network has been optimized. So I'd say, to date, 3 to 4 seconds is typically the average. I don't have a report just yet that shows here's my performance versus what we specified, but we are seeing results that are in line with our anticipations from the design. As we get more devices and more network deployed and more meters deployed, these things will be more important that we monitor, but for the moment, we're trying to deploy as much of the infrastructure as possible, and then we'll continue to watch.
Thank you, Kelly. Let me look, there's some more questions coming in. How do you utilize the line sensor data in the grand scheme of things? Are the line sensor data going to your SCADA system?
Yeah, so right now we have non-communicating line sensors across our service territory. The plan moving forward and integrating in with the DA program is we will be deploying smart intelligent line sensors that can communicate. The program philosophy around that will not be that I need them everywhere, because we also have reclosers, breakers, switchgear, other devices that can communicate outage data. So really the line sensors will be looked at to complement and enhance the view from those device types that we've already working on deploying, and looking for areas that I have poor visibility still or I need additional information. That being said, that's kind of the deployment side. Once I have those devices deployed, that data will ultimately come back into our SCADA system and into our DMS, in which case we'll leverage the fault magnitude to forecast fault location as part of our Recloser deployment.
There is another question, Kelly, back to the schemes when we talked about the centralized and decentralized schemes as well. And the question is if you think that 3 to 4 seconds latency is the issue for centralized scheme.
I'm not quite following.
If you have any comment on that.
I don't know what we mean is the issue. I think if the question is whether or not 3 to 4 seconds latency from device back to DMS is acceptable, I would say that it probably is by design. Our aspirations at Entergy are to restore a fault in less than 1 minute for our typical day-to-day outages. After that, as I mentioned, some of our industrial and hospitals and more sensitive customers, we have other special protection applications for that.
Yeah, and another question also related to the same topic. If you see any benefit in having the the centralized scheme in non-critical circuits?
Absolutely. So, centralized method gives you a broader view on the system and what's going on, right? So from a loading perspective, or, even integrating into DERMS down the road, being able to see, those hidden pockets of DER out there, you've just got a broader view. So I think anywhere that you can move to a more centralized approach, you do sacrifice a little bit of speed, but you trade that off with the benefit of being able to see broader in terms of what the impacts are and having a more optimized set of switching orders.
Thank you, Kelly. And I want to thank you also, the audience and the attendees, for all the questions and sending and using the Q&A during the session. Well, with that, I thank you again, Kelly, for the great presentation.